Yeah, my name is JaeHyuk Kwack, as just introduced. So yeah, I'm in the conference now, so my hotel Wi-Fi is not strong, so let me turn off my video. Okay, so for next 30 minutes, I'm gonna talk about the lightweight profiling tool available on Aurora. And after that, we are gonna have the Intel analyzer talk. So I also involved in that talk. And unfortunately, our Intel speaker had some unexpected accident a couple of days ago. So he cannot join in here to present the material. So I also got involved. So I'm gonna present that material as well. So uh, probably, yeah, today is a tool profiling tools day. I know yesterday you guys have probably see some PyTorch profiling method, and today is mainly the profiling tool. So this morning we have the Tau tool, and then just before this talk, John presented the HPC toolkit. These two tools are very popular and the portable across different architecture. So it's a pretty good profiling tools. Um, and Another choice of the profile tools could be something coming from the vendors, right? Chip vendors. So Aurora is definitely from Intel. So Intel also provide a set of the tools. So it's better than nothing, but many tools are not always better than one strong tool, right? So so at the very first time, the users can be confused about, okay, why this system has so many different tools and for which aspect I have to use which tool I have to use that, right? So I I just want to give you some kind of overview of those tools and features. And so when you started coding or running your application on Aurora, you can have some idea. Okay, I have this kind of issue. I need to look into this kind of the performance feature for that. Maybe I can try one of these tools like that, right? So I want to start from some lightweight tools. I always start with some easy things, right? So um, so the we have I'm going to talk about the three tools: iprof, which is developed at Argonne, and the unitrace from Intel, and xpu-smi from Intel. Okay, so uh, iprof is a tool from the THAPI. THAPI is Tracing Heterogeneous API, developed by the Argonne developers, Brice Bido, Thomas Ebuko, and Solomon. So they are part our team. We are very proud of this tool because this tool has very uh, small overhead from the tools, and also very intuitive CLI interface, and also some GUI interface, right? So TAPI is a portable programming model-centric tracing framework for heterogeneous system. It provides OpenCL, Level 0, CUDA, HIB, OMPT, and MPI API. And it also provides some device sampling, the features, and also power and the memory traffic, and some those features, right? So, and it has nice the visualization scheme using the Perpetual. So the default one is you can just see the data from the command line interface, and if you wanna see some GUI interface, you can use the Perpetual. So I will show you these two cases. So how to use the iprof from the Aurora? It's very simple. Just do the module load TAPI, and then you can just include iprof in your command line. So if you're using MPI, you can just MPI run, and then just put iprof in front of your application name. Okay, so in this case, iprof, the yellow color is placed between the MPI command line argument and then your user applications. So once you do that, it will show all the standard output from the applications, and then it will show the tracing data. So in this example, it is showing some MPI backend data. So MPI init, finalization, reduce, MPI reduce, and the com rank size. This is very simple benchmark, so you don't see a lot of activity, but in the real application, you can see many different MPI functions and how much time used, and then how much invocation happened, and average runtime, mean time, the max time, etc. Also, we provide OpenMP, the backend information. So here you can see the OpenMP functions, how much time used, and then the level 0 backend, which is default backend on Intel GPU side. So you can see the G module create, and so if you're not interested in it, you don't have to look into that. But if you're really like what happened under the hood, you can look into the level 0 function as well. And then it shows the device profiling. So this example, it just have only single the kernels called the compute COMP-GEO. So you can see the how much time used by COMP-GEO, and the device uh, the memory copies between the system and device, right? And here you can see the explicit memory traffic from the MPI backend and OpenMP backend, and also the level 0 backend. So it's pretty simple to use, and later in the demo, I will show you how to use that. So this is one of the lightweight tools we are recommending to use. So if you want to know what is your kernel time, if you want to compare the kernel time between the first configuration of input and second configuration input, you can just compare using the iprof to compare them. Okay, and then another lightweight tool is the unitrace, the unified tracing profiling tools. This is pretty similar to what iprof is doing, but it also has some difference between them. Okay, so this is a performance tools for the Intel One API application that traces and then profile host device activity, interaction, and hardware utilization for Intel GPU applications. So the unitrace is a part of the PTI GPU. Products. So if you go to this GitHub repository, you can see the more detailed explanation. So it provides the level 0 backend or level 0 plus OpenCL tracking profiling data, and also host activity, device activity, and some layers, different layers, right? For example, MPI layers, SQL layer, CCL layer, 1DNN layers about the level 0 on OpenCL backend. And also it categorize GPU kernels and also provide the hardware performance metrics. So Aurora also have THAPI interface. So if your application has already used the THAPI the instructions, you can use the THAPI. Or maybe if you don't have the THAPI interface in your application, and if you're interested in what is the performance counter data, you can use other tools, but also you can use unitrace to collect those hardware counter data directly from the device. Okay, so this is again this is lightweight tool, but it doesn't mean it has very limited features. It has a lot of features actually. So you can how to run the unitrace is unitrace and then option and then application. It's pretty similar to the iprof. And the available options are here. This is kind of selected one. So if dash D is the device timing, and the CCL summary report or device timeline, or dash Chrome, this option is using perpetual GUI interface. So if you use dash Chrome and then something, you can expect you can visualize those data on your perpetual from Chrome browser. Okay, so Chrome MPI logging, SQL logging, CCL logging, kernel logging, and also some metrics, metric sampling, and the device list and metric list. Okay, so I will show you the example later, but yeah, pretty similar the interface like iprof. So this is some example of the MPI layers, and SQL layer and CCL layers. So once you run with the Chrome MPI logging, you can you will have the JSON file, and then once you load JSON file on the perpetual, you can see this kind of MPI activity, SQL activity, and the CCL logging activity. So how to use unitrace? So you just need to load the PTI GPU, because this is unitrace is part of the PTI GPU product. So just module load PTI GPU, and then just type unitrace device list. You can see the 6 GPUs and the metric list. You can see so many groups of the metrics. So yeah, we'll try it out later. Okay. So this is basic instruction to use unitrace on the advisor. No, on Aurora. Sorry. So last lightweight tool is xpu-smi, Intel XPU System Management Interface. So if you are if you are a user of the NVIDIA GPU systems, so I think many users enjoy to using the NVIDIA SMI. This is a very native tool, and you can see GPU activity through NVIDIA SMI pretty quickly, right? So this is not really delicate tool, but it's very easy to use, right? So XPSMI is something like the NVIDIA SMI on NVIDIA side, from the Intel side. So NVIDIA XPSMI provide very similar features on Intel GPUs. So it has a gigabit repository. So if you go to here, you can see more the options, how to use that, okay? So this tool is to monitor and manage Intel data center GPU, and it's designed to simplify administrations and maximize reliability and uptime and improve utilization. XPU Manager requires some daemon, but XPSMI is a daemonless version of the XPU Manager, so the users can use it. So how to use XPSMI on Aurora? Pretty simple. Just module load XPSMI, and then you can use XPSMI, right? So XPSMI discovery will show what kind of the devices are available. And this is one example how to see the XPSMI data in every second from the different devices and different metrics. So we will do it together with demo, okay? Okay, so this is a very quick overview of three different tools, iprof and unitrace and XPSMI. So before we start the demo, do you guys have any questions? Yeah, basically, I will talk about many different tools. So I think if you have any question, don't hesitate asking. Just speak up in the middle I'm talking, or just put on the Slack. So as yeah, I think John already showed his channel, but we also have a channel for Intel tools. So you can go to profile Intel, and then if you have any question, just leave it here. Okay. Okay, I'm hearing none. So let me move on the demo. Okay, so I have the node here. Okay, so I already got the node. So what you need to do is you need to copy. I already put some example on the GPU hack project space. So just copy examples and tools Intel to your home directory. Okay, so cp-r, rooster, and Flare and project and GPU hack example and tools, and I will copy to my home folder. Okay, and once you do that, you can go to. By the way, Yasi, can you see my terminal, or is it
Yes. Yeah.
the font is okay? Okay.
Yes, it looks good. Thank you.
Okay. So let me go to the tools, the Intel here, and I just copied it here, right? So okay, and then what you need to do is you just need to make run the make, and then it will generate the two executable. The first executable is for the profiling. The second one we don't use it today. So here, one thing you need to know is when I build this application, I use this is OpenMP benchmark, so I use some flag for OpenMP. And I use these two flag. This is not required for the tools, but if you have them, that is better for the source line level the analysis later. So this is not required if you want to have a kernel-based analysis, but if you want to do some line-by-line analysis, you need to build your application with these two flag. So basically, you can use -G, but -G has so many symbols for the debuggers. So sometimes -G is too much and it has more overhead. So yeah, these two flag, just remember it and then build it, right? So how to run this application is npi-run 12 because I just got one node and GPU type compact for GPU affinity, and then clump OMP and DP, and let me 2048 and 1000. Let me use the command argument, right? And then just run the 12 ampere rank. It's very, very simple FMA instruction. And you can see 55 terabyte teraflops. You get it, right? So this is your example code, and then let me show you how to use iprof. Okay, so first of all, I need to load THAPI module, right? And then I can check if I can see the iprof file or not, right? So iprof is available, right? And then the previous command line without running the running without tool is this one, right? So here, and in order to use the iprof, you just need to add iprof in front of your application executable binary. Okay, so I just put iprof here, and then run it again.
And JaeHyuk, that's a basic iprof. If you want to have more
Yep.
descriptor, you have to put comments in front of it, right?
Yeah, right. So after iprop, we have several different the options. So this is the basic one, right? So you can see again the MPI, OpenMP, and level 0. And if you have a corner of interest, you can see how much time is used and min max and etc. Right? So as Yasi mentioned, this is very, very simple. Just basic options, but you can see here there are so many different options here, right? So you can also choose the backend. The default one is choosing collecting everyone, but if you want to reduce some overhead, so this is a very simple benchmark. You don't see much overhead, but if you run real application, you may see some overhead coming from the iProp, right? So you can choose the backend, you can choose the trace mode, and you can choose the rankage, right? Because iprop can handle the MPI case pretty well, so you don't see multiple output file. It just accumulate for the entire application and provide the accumulated data here, right? So, which is pretty good. And also, iprop provides some perpetual the interface, GUI interface. So if you want to see some timeline view, you can add the dash L after iprof. Then if you run it, huh. It worked, right? And then iprof, nice H and dash L timeline, petal. Oh, okay. So yeah, after iprop, we have to dash dash because iprop needs to know which one is flag for iprop and which one is binary, right? So iprop dash L and dash dash, and then the executable binary, and then it should be okay. Yeah, it's running here, right? And then it says output out.p pf trace is created. You can see here out.pf trace is created, right? So I tested it an hour ago, and I already downloaded it. So if you look at that, you can just go to the perpetual UI and then go here. And I have downloaded out the ptrace file here. So you just drag and drop here, and you can see this is very simple benchmark. So you don't see a lot of activity here, but again, you can see the 12 MPI rank, MPI init, GE, and if you zoom in here, you can see the OMP target and G event host synchronization and etc. Right? So yeah, this is so if you're interested in the timeline view, you can always use perpetual and using the L option. So you can do that. So this is a demo for the iprop and unitrace. Let me try to. Yeah, let me load PTI GPU for the unitrace, and then unitrace is available here. So in the unitrace, if you see the device list, it shows how many GPU you have and what is the PCIe address here, right? So, and then if you if you're interested in the hardware counter data, you can just type the metric list. And you can see a lot of different metrics and different groups, right? So if you just grab the groups, it has a 716 groups, and many of them are overlapped each other. So you can see hardware counter data per the vector engine, specific vector engine, or the thread dispatcher, or some cache, L1 cache and L3 cache, and the data port, and etc. Right? So yeah, if you want to see some specific hardware counter data, you can also using the metric query and then collect those data. Okay. So unfortunately, unitrace, if you run the unitrace like iprof, unitrace provide output from the every MPI rank. It is a little bit messy. So yeah, you can see this kind of data here, right? But if you think each MPI rank runs similar kind of workload, you can use npmd mode, which means you just attach unitrace to one of the MPI rank. In this case, I run this application without unitrace for the 11 MPI rank, and then for last MPI rank, I attach the unitrace here, right? So if I use this setup. This one, npmd mode here, right? So I use this one. You can see only one input coming from the last the MPI rank. So it shows API time summary, level 0 backend, and device time summary, and level 0 backend again, and the kernel property as well, right? So here it has OpenMP upload compgeo one. So if you compare unit trace data and iprof data for the same runs, it's pretty similar to each other because they are using same level 0 tracing. Okay, and you may want to use the perpetual GUI interface. So in this case, we can use we don't have to use the npmd mode, so I use npm run -12 GPU compact and unit trace and Chrome kernel logging and the Chrome MPI logging, and then I use conf geo and 2048 1000. If I run it, it generates the 12 different JSON files. So you can see the 12 different JSON files here, right? And then I already downloaded some of them before, so I will just use them. So, and in the Perpetual, you can just bring one of them here, right? So this is the MPI rank 11. So if you open it up, you can see we collected the kernel logging and then the MPI logging. So you can see these two types of the logging you just here, right? So it has MPI init here and it start execution. So you can see this is G event host synchronization and OpenMP offloading, which is pretty similar to the what you have seen what you have seen from the iprof data, right? So here, so you can use the perpetual for unit trace as well. Okay, so this is the example of the unit trace, and then the last one is xpu-smi. So how to use it is module load xpu-smi, and then smi you can see that. So xpu-smi -h, you can see additional options here, and xpu-smi discovery. you can see the available device. So you can see the 6 GPU devices available on this node, right? And then xpu-smi dash help dump. This is it. The convenient way to see the data. So you can see dash G, and you can specify which device ID you want to see, right? And dash M, you can choose what kind of the metrics you wanna choose. So I'm interested in GPU utilization, power, frequency, and then memory temperature utilization and read, right? If so, you can just do the xpu-smi. And the dump and dash G, I will just see first and the second GPU, and then dash M, 0, 1, 2, 4, 5. Okay. So if you type that, you can see the timestamp and the device ID, utilization, GPU power, and frequency, right? So right now, I'm not running anything on this GPU, so you can see no utilization here. But what you can do is you open up another X11 window terminal, and then if you go to this node, right? So you can do the SSH, this node. Oh, thank you, Ricardo. Yeah, Perpetual. You can just Google the Perpetual, or you can use the link what Ricardo just paste on the Slack channel. You can use that. Okay. So module load xpu-smi, and then let me start it here. Okay. So if I run this one on the additional SSH, you can see you're watching xpu-smi on this terminal. You're on the same node, right? Because you did SSH, right? And then if I run GPU tile compact, then conf np SEC, and no, it's a little bit longer. I'm not sure, this is too short, so I'm not sure xpu-smi can catch it or not. Not maybe. Yeah, maybe if you run some bigger application, real application running longer than a couple of seconds, you probably see that. Okay, so this is not this is a kind of not traditional profilers, but if you wanna see what is your GPU activity in real time, that could be a good tool to try it out. Okay, so. Yeah, this is the demo for the 3 tools, iprof, unitrace, and xpu-smi. Do you guys have any questions
I
about
have
that?
one quick question, JaeHyuk. So between the unitrace and the iprof,
Hmm.
and you show that their sort of output is very similar, what would you recommend their usage would be like for a user to use which one in what
I
cases?
definitely I definitely recommend to use iprof because uh, if we have developers at our group. So if we see any issues or any feature requests, we can bother our developer pretty quickly. So in terms of the tools features are slightly different between them. Okay, so as I mentioned before, if you are interested in some power-based data, recently, iprof has some extension for the power measurement. So for that feature, you can use that. But if you wanna see some specific hardware metric data, for example, if you wanna see some L3 cache bandwidth or traffic, something like that, unitrace will be better than iprof. But in general, lightweight the tracing tool, in my opinion, iprof and unitrace both provide pretty good features. Okay, so either of them are okay, but again, iprof is developed the Argon, so I would recommend to use iprof.